this is for Year 11 methods. We're going to look at question 5 from exercise 5F, okay? So we've got a quadratic function, f, such that f of 2 equals f of 4 equals 0. Now, we're going to interpret what this actually means, okay? F of 2 equals 0, f of 2 equals 0, and f of 4 equals 0 are a specific type of point. If you write in corner form, you notice there x-intercepts, okay? So we've got x-intercepts at 2 and 4, and the greatest value, the max value, or the maximum y value of the function is 7. So max of f of x equals 7, okay? Now, before we go dealing with equations, we've got to get understanding what it looks like, okay? So we know the graph has intercepts at 2 and 4, and the max value is going to be at 7, okay? Now, what's my x value? Well, I can work out my x value because remember the axis of symmetry. If I go in the middle, that must be a 3, okay? The middle of 2 and 4 is 3. So I've actually got 3 coordinates, okay? Now, I can get the quadratic function by using the 3 coordinates. I've got 1, 2, 3. So what I'm going to do is I'm going to define a function, f of x equals ax squared plus bx plus c. So I'm going to use the general polynomial form for a quadratic, and I'm going to sub this into simultaneous and solve it. So I'm going to define the function first. So first step is to define your function. 1, define function. 2, simultaneous to solve, okay? So you can do this all on the CAS, okay? So I'm going to go on my CAS. I'm going to clear all. Now I want to go ax squared plus bx plus c. Okay, so ax squared plus bx plus c. Okay, I'm going to define that function because this is my general quadratic equation, okay? Interactive, define. Now I'm going to solve simultaneous equation. Now, how many simultaneous equations do I have? I've got 3 unknown variables. Okay, so I've got a, b, and c, and I've got 3 coordinates to sub in. So I'm going to have to have 3 rows. So we know f of 2 equals 0, f of 4 equals 0, and f of 3 equals 7, because the turning point when x equals 3, our function equals 7 or y equals 7. Okay, and we're solving for a, b, and c. Great. So we've got our equation. So we've got y equals negative 7x plus x squared plus 42 minus 56. So f of x equals 7x squared. Was it minus 42? Okay, minus 7x squared plus 42 minus 56. Plus 42x minus 50, plus 56 minus 56. So that's basically how you approach this question. Now, I guess the shortcut way to do this is, because you know it's a quadratic, you can use spreadsheet. So you can go, I'll get rid of this. You can use spreadsheet if you want to. Now, a spreadsheet's only useful if you get whole numbers, okay? So if you don't get whole numbers, so your first coordinate's 2, 0, you got 4, 0, and you got 3, 7. So what you're going to do is you're going to highlight it. Let's highlight everything. Calc, regression, quadratic regression. And you see, in this case, the quadratic model spits out nice whole numbers or numbers that have terminating decimals. If they don't, then that method's not good for you. You have to do it the long way, which is what I've done. But both ways are fine. So hopefully that gives you an idea of how to approach a question like this on the CAS calculator.